Friends, now we will see one university question for JNTU. This is on matrix displacement method. This university question is for the year May 2018 for JNTU. The problem is shown in this diagram. We have two span continuous beam. Span AB is loaded with one point loaded 30 kilonewton at midspan. Span BC is loaded with point load of 50 kilonewton at midspan. AB, BC, the dimensions are given as 6 meter and 4 meter span respectively. Now, support A is fixed, B is simply supported, C is simply supported. We have two displacements. One displacement at B in the form of rotation, that is theta B. Another displacement at C in the form of rotation, that is theta C. Theta B, theta C are the two displacements, that is two rotations. So the degree of freedom is 2. Degree of freedom or kinematic redundancy is 2 because there are two displacements in the form of rotations, theta B and theta C. Now we have to calculate the final moments MA, MB, MC. That is the analysis of the beam. Now the given beam is treated on par with a fixed beam at all the supports with fixity. Then we are deriving the given beam by adding the impact of the moments caused by the rotations theta B and theta C. That is the approach followed. So the fixed moments are calculated. Then for calculation of the moments caused by the rotations, what we are doing is we are calculating the moment caused by unit rotation at B and C. And this unit, the moment caused by unit rotation is multiplied by theta B and theta C for obtaining the final moments. This rotation, this moment caused by unit rotation is called stiffness. The moment caused by unit rotation, if multiplied by the actual rotation, will give the final moments. Therefore, the final moment is nothing but the stiffness into the actual rotation. So this moment is added to the fixed end moment for getting the final moments. Now first we will calculate the fixed end moment. This is for the span AB, WL by 8. This is at A it is anti-clockwise direction, at B it is in clockwise direction, therefore minus for at M of AB. For M of BA it is 22.5 plus. Similarly for BC, if it is treated as fixed at B, it is anti-clockwise here, minus sign for M of BC, and at C it is clockwise, therefore M of CB is 50 kilonewton meter. The formula is WL by 8. Now we have to calculate the effect of the rotations at B and C. At B, if you introduce unit rotation, what is the moment at B? That is called K11. We have two displacements, that is delta 1 and delta 2. K11 means that is you introduce unit rotation at B and find out the moment at B. That is called K11. The second subscript denotes the rotation applied. The first subscript denotes the moment where it is measured. The rotation is applied at 1 and moment impact is measured at 1. So that is equal to 4 EI by L plus 4 EI by L on either side. This is 4 EI by 6 and 4 EI by 8. That comes to 1.167 EI. Similarly, K21. K21 means 1 is the point where unit rotation is applied. 2 is the point where the moment is measured. That is at point C. So for K21, it is equal to 2 EI by 8. Because we are measuring the moment at 2. The displacement 2, that is displacement 2 corresponds to point C. It is the farther end. This is the place where moment is measured. In the first place, the moment was introduced here and we calculated MBA and MBC.
Therefore, it is 4 EI by L. It is near end. For now, we are introducing the rotation at 1 and we are measuring the moment at 2. So this point 2 is farther end. So for this, it is 2 EI by L. Similarly, we have to calculate K12, which is again equal to K21, or you can also calculate K21 means K12 means you apply unit rotation at 2 and calculate the rotation at 1. So it is farther end 2 EI by 8. It is 0.25 EI again. Now K22 means apply the unit rotation at 2 and measure the moment at 2. So it is 4 EI by 8. It is 0.5 EI. Now we have the net moments at F1 and F2 should be calculated. F1, F2 are the displacement points. At F1, you have two fixed moments, 22.5 and minus 50. The net moment is this much. And at displacement 2, that is point C, the net moment is 50 kilonewton meter. Now, this is the fixed moment, net fixed moment. Now, K matrix denotes the movement caused by unit rotation. This multiplied by the actual rotation will be equal to the total moment. That is the equation here. For the K1, we are having two displacements. So the matrix is 2 by 2. We have written down all the elements K11, K21, K12, etc. And there are two rotations, delta 1, delta 2, which is nothing but theta B and theta C. And here we have substituted the values K11, K21, K12, and K22. And this is equal to the net moment, that is minus F. This is the equation, K delta is equal to minus F. And we can bring the term EI outside, and then we have this inverse matrix on the right hand side. After solving, we will get EI into theta B is equal to 50.384 and EI into theta C is equal to this much. Then we have the member matrix, that is, we have the equation for the moment in terms of fixed moment and the moment caused by the rotation. For example, MAB is equal to M of AB plus the rotation caused by theta B. This theta B is the farther end. So it is 2 EI by L times theta B. Then what about theta A? Theta A is equal to 0. It is fixed. So therefore, MAB is obtained by using the member matrix relationship. Similarly, we can get the moment BA. It is equal to the fixed end moment plus the rotation caused at B, and what is the moment caused by that? Theta B is the rotation. It is the near side end. Therefore, 2 EI by L into 2 times theta B. That is 4 EI by L. Therefore, this is the final moment MB. MC is being the simply supported end. It is equal to 0. So we have got MBA, MBC using the member relationship between the fixed end moment and the actual rotations. Now we can draw the simply supported bending moment diagram, that is equal to WL by 4. For this span, if you use WL by 4, you will get this moment. And similarly, if you calculate the moment WL by 4, you will get this total ordinate. But this net ordinate is the sum of the simply supported bending moment ordinate plus the fixed end bending moment ordinate. This is the simply supported bending moment and this is the fixed end moment. Average of the two values will give you the negative bending moment at midspan. The net bending moment is positive. It is 14.1 at point D. That is midspan of AB. Similarly, midspan of C, that is point E. The bending moment due to simply supported effect is WL by 4, 50 into 8 by 4 minus the negative bending moment. It is 56.1 at one end and 0 at the other end. Therefore, at midspan, it is equal to 56.1 by 2. Sum of these two is 71.95. So this is the net bending moment ordinate. And we can also plot the bending moment diagram on the tension side. At support, the negative bending moment causes tension at top. So plot it on the upward side. And then here, if it is 14.1, simply supported bending moment, it is causing tension at bottom. Plot it below the line. Between points A and D, there is no load. So join it by means of a straight line. Similarly, at B, the net bending moment is 56.1. It is causing tension at top. Plot it above and join these 2 points by straight line because there is no load between point D and B. At point C, the bending moment is 0. Here, the moment is calculated as 71.95. It is equal to the sum of the simply supported moment plus the negative moment. It is positive. It is causing tension at bottom. Plot it at bottom and join these 2 by means of a straight line because there is no load in between the points B and E. So the bending moment diagram can be plotted on the tension side also. And for all the explanations, such as what is the relationship between the actual moment and the fixed end moment and also the rotations, and what is the moment introduced corresponding to unit rotation, what is the relationship between the moment impacted due to applied rotation, theta B or theta C. For all these explanations, you can refer this website, https://rgnsite.wordpress.com. There are about 500 university questions and answers, including this one. The 500 university questions and answers will address various structural engineering topics such as RCC design, steel design, strength of materials, structural analysis, volume 1, volume 2, etc. It is available for free download, including this page. Including this page, you can have the download free, and there are a lot of one-word university questions and answers which will give various explanations. So please visit the site rgnsite.wordpress.com and have the free download of all the blog materials. Thank you.